Okay guys, so the first topic of today is system of equations, and we're going to solve them algebraically using elimination. So just as a reminder, what is a system of equation? It's more than one equation. So we're basically going to be comparing two lines, seeing if they have anything in common, and like 1 point, no points, or maybe all the points. So elimination is the process of eliminating equations by isolating one variable, so x or y. In order for this to work, though, you need additive inverses, which are numbers that add to 0. So basically opposite numbers. So first example is when you look at a problem, you're going to want to use this method to solve when you have the x's lined up, the y's lined up in the numbers back in standard form. So the question is, first, can you spot additive inverses? Well, here, just circle this. Those are additive inverses. So that means elimination would be a good method. Here, there are none. So this one, and we're going to practice this, is a special case where we're going to multiply to make the inverses. We're going to practice that. Now, none of this is new. You definitely did systems of equations through Algebra 1. Now we're just kind of dusting off the cobwebs to try to make sure we remember this stuff. So just kind of gave you here the steps in a little flow chart. So flow chart. We're going to kind of follow these steps, guys. Basically, you want to make sure you line up the equations. X is above x's, y is above y, so just like you saw up there. Then if you have opposite coefficients, if you say yes, you just add the two equations together. If you say no, then you have to multiply the equations. That's what I was saying. And then we'll figure out. So this is always your go-to chart if you need. So let's turn the page and let's start solving, because I think once you see a couple, you'll remember it. So, first example here. Again, x is lined up, y is lined up, numbers lined up, perfect. Find the additive inverses is the hope. You can see you have a positive 4 and a negative 4. So by adding together, I just set it up like an old school addition problem. We're at 1x plus 2x is 3x. These would make the 0, so cross it off, equals 9. So you can see, since these were the opposite numbers, we eliminated y. That's why it's called elimination. Then, to finish solving for x, the opposite of multiplying by 3, divided by 3, so x equals 3. Now, the only one stipulation with the system of equations is we're trying to find a coordinate point that they have in common. So a coordinate point is an x and a y. So after you do that, okay, that was all step 1, you have to plug this in. Now, where do you plug it into? You can pick the first equation or the second. I'm just going to pick the first. And you're going to do the math and then solve for y. Okay, so we're going to take the first equation again. X plus 4y equals 19. And I'm going to plug in 3. 3 plus 4y equals 19. So you can see all I did was replace the x with the number 3. And now I'm going to solve the equation for the y. So subtract 3. And then I get 4y equals 16. Then I divide by 4. So y equals 4. And there's my answer. Now, sorry, I should have circled both of them. Together, they are my answer. So as a coordinate point, it's 3, 4. So for multiple choice questions, when it comes to this, they're going to show the coordinate point. But that's all there is to it, guys. Let's take a look at the second one. Again, x is lined up, y is lined up, numbers lined up. Good. Already both the way it should be. So now you can find the additive inverses. So again, this one's going to eliminate the y, because when I add them together, these two will make 0. So you can cross those off right away. 4 plus 1x is 5x. 18 plus 7 is 25. Try not to lose your equation in there, because sometimes people get all the numbers mixed up. Now to solve for x, the opposite of multiplying by 5 is dividing by 5. So x equals 5. And just like before, this is not your final answer, okay? You have to pick the top or the bottom to plug this in for x. So I'm just going to pick the bottom one Doesn't really matter. You can always keep picking top. Doesn't matter. As long as you do your math correctly, you'll get the same answer. So I'm picking the bottom equation. I'm going to plug 5 into here for x and solve for y. So most of you probably remember a good amount of this. But if not, that's what this practice is for. And then divide by 2. So again, both answers are my solution, okay? And it's, again, if we're graphing, which we're going to do later today, is that's going to be my coordinate point. So for every problem, you want to make sure the x's are lined up, the y's are lined up, and you want to make sure you have opposite numbers so that when you add them, those are those inverses to make 0. So clearly we can see here, x's are lined up, y's are lined up, numbers are lined up. Now we have opposite numbers here, but I don't care about the actual constants without letters. It's these or these you want to be opposite. You could really pick whatever you want, but I'm going to pick the y's to make opposite. This is a positive 1, and that's a negative 2. So in this case, sometimes you're going to have to manipulate an equation. I'm going to multiply the entire top equation by positive 2. That way, I will get a positive 2y, and I can add it with this and then get rid of the y's. So I'm going to do distributive property. I always draw my lines. Too many people forget any one number. You have to multiply the entire top equation by 2. So when I do that, I'll draw a little arrow showing that I did that. I get 4x plus 2y equals 14. So again, now that you have your new top equation, put your old bottom one underneath it. Take your time when it comes to setting up the numbers, because if not, it's the little things that can merely screw it up. And then now look, now we have the y's are opposite and we can just do the addition. So 4x plus 3x is 7x. Cross off the y's because they make 0. Equals 14 plus negative 7 is positive 7. So when I divide by 7, I get x equals 1. So again, this is only part of your answer. You have to go back. Don't go to the ones we changed. Go to the original 2 and pick the top or the bottom, the original 2, and plug this back in. So I'm going to pick the top one. So that's just me rewriting the top one, and I'm going to substitute 1 in for x to do the math. Okay, so 2 times 1 is 2. And notice I just keep writing, organize your information, it will work every time. Opposite of adding 2 is subtracting 2. So y must equal 5. So again, both of these are your solution. They make one coordinate point, so this is going to be your answer that you would find on a multiple choice. So you can see I'm going to be doing the same thing each time, so let's take a look. I'm going to actually switch it up here. Sure, I could multiply the y's. I could do what I did up here and multiply this whole thing by positive 2, because again, I don't have opposites. But instead, just to switch it up on you, I'm going to multiply this whole thing by negative 3. By doing so, I'm going to have a positive 3x here and a negative 3x down here. So I'm going to make sure I multiply everything by negative 3. So when I do that, I get negative 3x, negative 3y equals negative 45. Again, I could have just doubled it and then eliminated y, but now I'm just switching it up. Let's try to eliminate x. Take the original top equation, put it back on top, like so. And then look, you already have opposite x's, which is great. So we can add them together and eliminate. Cross them off because they're going to make 0x. But negative 2 plus negative 3 is negative 5y. 5 plus negative 45 is negative 40. So all you have to do, don't add 5 over. The opposite of multiplying by negative 5 is dividing by negative 5. So y equals 8. Now again, this is only part of your answer. You have to get an x and a y. So go back to your original 2, okay, here and here. Decide which one you want to pick it into. I'm just going to pick the bottom one before, just the original typed problem. I'm going to plug this in. So, okay, I'm going to pick the bottom one, so I just picking it here. And then that being said, now I'm going to substitute 8 in for y. So x plus 8 equals 15. And then I'm going to subtract the 8. So x equals 15 minus 8, 7. So again, both numbers are your answer, and you write them as a coordinate point. Always x before y. Just remember the alphabet. So again, this is not your first time seeing it. It has been a while since you've used systems of equations. We're going to keep practicing, but this method is the elimination method. Now sometimes you notice these two, we didn't multiply, we just straight up added. These two, we had to multiply one of the equations. Okay. Now, looking here at this example, as you turn the page, you're going to have to multiply both of them. Okay, both of them. Now, at this point, it's all free reign. You could choose to eliminate the x or the y. Doesn't really matter. I'll choose to eliminate the x. So I have to think to myself, what's the lowest number 5 and 2 will both go into? That's 10. So in order for me to make this top 5x a 10, I'm going to multiply this whole thing by positive 2. So I'm just going to distribute. Let's take care of that. So then that's going to make 10x plus 6y equals 28 times 2, 56. Remember, you get your calculator just to make sure the math's right. Now, if this equation I made a positive 10x, then in order to add them, I'm not going to just multiply this by positive 5. I have to multiply it by a negative 5 because I want opposite numbers. So again, I'm going to take every number and multiply it by negative 5. So then that's going to make negative 10x, negative 10y, and then 16 times negative 5 equals negative 80. Now look, now you've had it set up perfectly so that you can straight up add them and get rid of the x values, which is nice, okay? So we'll just eliminate, and then do the math. 6 plus negative 10 is negative 4y equals 56 plus negative 80. Type that in the calculator. I got negative 24. Then the opposite of multiplying by negative 4 is dividing by negative 4. So y is going to equal 6. Now, like I said before, this is just part of your answer, guys. So from there, what you have to do is take this, go back to the original, the typed problem, and just choose top or bottom. I'll pick the bottom one just because the numbers are smaller, make it a little easy. You could pick the top, it doesn't matter, and plug 6 back in and solve for x. So I'm just going to rewrite the problem first so I get it all organized. Now I'm going to substitute. So all I did was choose the second equation. I'm going to substitute 6 in for y. So do the math. So it's going to say 2x plus 12 equals 16. Opposite of adding 12, subtracting. And then I'm going to divide by 2. So x equals 2. So again, both are your solution, and you write it like a coordinate point. That means the two lines are going to hit at that point. So again, sometimes, just recapping, you don't have to multiply anything. You could just straight up add as long as you already have the opposite additive inverse numbers. Sometimes you only have to multiply one of the equations in order to get the opposite numbers and then add them up. Sometimes you have to multiply both of them. That's a little bit more freedom, okay? Last example here, just to make sure we're all clear, you could say to yourself, what should I do? Should I eliminate the x's? Should I eliminate the y's? Well, we don't have any opposite numbers. Now you could pick. We could multiply the top one by negative 1 so that we have opposite x's, or you could just multiply the top one by 2. I'm just going to double this, and the whole reason why I'm doubling it, guys, is this will make a 2y, and that's already a negative 2. So when I double it, I get 6x plus 2y equals 34. And then down here would be the 3x minus, so I didn't change the bottom equation. And then I have to add these together. 6x plus 3x is 9x. Those will cancel. 34 plus 2 equals 36. And now all you have to do is divide by 9. So x equals 4. And then from there, again, guys, you could go back to the original type problem and choose to plug it into here or plug it into here. So I'm going to pick the top one, and so I'm just going to rewrite it right here. And let me substitute 4 in for x. So you can see where the x was, I substituted it in, just plugged it in, and now I'm going to do the math and solve for the y. So 3 times 4 is 12. And then subtract the 12. So again, these two are our final answers. Together, they make a coordinate point. So again, it just means that when those two lines are graphed, which we'll be talking about today, they're going to hit at 4 or 5. So there's one solution. So all these examples had one solution. Sometimes there's no solution. Sometimes there's infinitely many. And we're going to work more with that, but we're going to start with these basic stuff. So finding an x and a y. So you have 3 problems for classwork on this today, and then we're going to work into graphing the system. So each time I'm going to have a video that goes over the answers and then goes over the notes. So try the 3 problems on practice classwork. Take about 5 to 10 minutes tops, and then you'll see the video on it.